Okay, so a quick video on this relatively difficult SAT question number 29, test number 3. Um, and what they have is they give you this chart and they say that the entire number of left-handed students is 18. And we have male and female. It says there are 5 times as many right-handed female students as there are left-handed female students. So we know that this number is 5 times this number. And it says, and there are 9 times as many right-handed male students. So we know this is 9 times this. And then we also know that if we add up all the right-handed females and all the right-handed males, it adds up to 122. We add up all the left-handed females and the left-handed males, it adds up to 18. And we somehow have to pull all that out and figure out which of the following is the closest to the probability that a right-handed student selected at random is female. So let's give this a try. So first of all, give it variables. I'm calling right-handed females RF, left-handed females LF, right-handed males RM, left-handed males LM. And we know that if we take all the right-handed females and right-handed males, all the right-handers adds up to 122. If we take all the left-handed females and all the left-handed males, that adds up to 18. But we also know that the right-handed females are 5 times as much as the left-handed females. So RF equals 5 times LF. And the right-handed males are 9 times the left-handed males. Therefore, we can replace this RF with 5LF. So RF equals 5LF. So let's rewrite this down here. RF plus RM equaled 122. We're going to replace RF with 5 times LF since they equal each other. So let's just make that 5LF. So we just substituted that. And we know that RM is 9LM. So we're going to take this and substitute that RM with 9LM. So RM is 9LM. And so since RF plus RM equaled 122, this also equals 122, since that equaled that and that equaled that. So now let's write our second equation down here. LF plus LM equals 18. So look, this is all the left-handed females and all the left-handed males. We take all of them together, we get 18. And then 122 is all the right-handers, but we now just put the right-handed numbers in terms of the left-handed numbers. So 5 times the left-handed females and 9 times the left-handed males gives us this 122. So all the right-handers are 5 times the left-handers plus 9 times the left-handed males. Okay, now we're going to say we need to use substitution or elimination to get rid of one of these. So let's say that LF equals 18 minus LM by subtracting LM from both sides. Now we have LF all by itself, and we know that LF equals 18 minus LM. So then in our top equation, 5, it was going to multiply by LF, but LF is 18 minus LM. So let's just put 18 minus LM in there, plus 9LM equals 122. And then now we can start solving. 5 times 18 is 90. Minus, we distribute that out, 5LM plus 9LM equals 122. we're going to have negative 5LM plus 9LM is going to give us 4LM. We're going to subtract 90 from both sides and get 32. So now we have the left-handed males are 8. Now we've got the left-handed males, that was 8. All right, and we knew that the right-handed males are 9 times bigger, so 9 times 8 gives us 72. That gives us the, if there's total 18 and 8 of them are males, then that gives us 10 females. And then there's 5 times as many right-handed females, gives us 50 right-handed males. And we've got 50 right-handed females, 72 males for a total of 122. The question is, what's the percentage or probability that a right-handed student selected at random is female? Well, there's 122 total right-handed students that we're picking from, and there are 50 females, so 50 divided by 122 gives you about a 0.41 probability. Pretty tough question.